Hi, welcome all. Let us today study the derivation of Gregory Newton forward interpolation formula. So this is a part of a topic in your second chapter, numerical methods. First of all, what is finite difference? Basically, numerical method is a technique of solving a mathematical problem using the data, numerical data, and not with an analytical equation. So basically there are two methods in mathematics. One is called as the analytical techniques and the second is called numerical methods. Analytical technique uses a theory or an equation or a formula and it solves a problem. Whereas it doesn't use a numerical data. But in numerical method, using a available data, numerical data, we try to find out or try to estimate the unknown value of y for a known value of x. So that is what we call as numerical method. So basically it deals with the variation in a function. So what is a calculus of finite difference? That is that plays an important role in numerical methods. The calculus of finite difference deals with the variations in a function when the independent variable changes by finite values which may be equal or unequal. In this section we shall study the variations in a function due to the changes in the independent variable by equal intervals. ന്യൂമറിക്കൽ മെത്തേഡിലെ പ്രധാനപ്പെട്ട ഒരു ഭാഗമാണ് കാൽക്കുലസ് ഓഫ് ഫൈനൈറ്റ് ഡിഫറൻസ്. ഒരു ഫംഗ്ഷൻ ഇൻഡിപെൻഡന്റ് വേരിയബിൾ എക്സ് അത് ഈക്വലോ അൺഈക്വലോ ആയിട്ട് മാറുമ്പോൾ അതുകൊണ്ടുണ്ടാകുന്ന ഫംഗ്ഷന്റെ മാറ്റങ്ങളെ കുറിച്ച് നമ്മൾ മനസ്സിലാക്കുകയാണ് ചെയ്യുന്നത്. ഈ സെക്ഷനിൽ നമ്മൾ ഈക്വൽ വേരിയേഷൻസ്, എക്സ് ഈക്വൽ ആയിട്ട് വേരി ചെയ്യുമ്പോൾ ഫംഗ്ഷന്റെ വേരിയേഷൻസിൽ നിന്നും നമുക്ക് ന്യൂമറിക്കൽ ഡെറിവേറ്റീവ് കാൽക്കുലേറ്റ് ചെയ്യാൻ പറ്റും. അതുപോലെ ഇന്റർപോളേഷനും നമുക്ക് സാധിക്കാൻ പറ്റും. First of all, what is a finite difference operator? Let us say y is f of x is a function, is a discrete function. So this is a discrete function എന്ന് പറഞ്ഞാൽ കണ്ടിന്യൂസ് അല്ല, എല്ലാ പോയിന്റിലും ഇല്ല. x0, x0 plus h, x0 plus 2h, etc. x0 and h are the successive values of x. x ന്റെ values ഈ discrete pointsലാണ് അവൈലബിൾ ആയിട്ടുള്ളത്. When two consecutive values differ by a quantity h, then the corresponding values of y are y0, y1, y2, etc. up to yn. The value of the independent variable x is usually called the argument and the corresponding functional value is called the entry. The argument and entries can be shown in a tabular form. x0, x0 plus h എന്ന് പറയുന്ന x ന്റെ വാല്യൂസിന് കറസ്പോണ്ടിങ് ആയിട്ട് നമ്മൾക്ക് y0, y1, y2, yn അങ്ങനെ y വാല്യൂസ് ഉണ്ട്. ഇൻഡിപെൻഡന്റ് വേരിയബിൾസിന്റെ വാല്യൂസിന് പറയുന്ന പേരാണ് ആർഗ്യുമെന്റ് എന്നും, അതുപോലെ ഫങ്ഷൻസ് y വാല്യൂവിന്റെ പേരാണ് എൻട്രി എന്നും പറയും. ഒരു ടേബിളിൽ നമുക്ക് കാണാൻ സാധിക്കും ഇതൊരു ഡിസ്ക്രീറ്റ് ഫംഗ്ഷൻ ആയതുകൊണ്ട് ചില എക്സ് പോയിന്റ്സ് എല്ലാ എക്സ് വാല്യൂസിലും ഉണ്ടാവില്ല, ചില എക്സ് പോയിന്റ്സിൽ മാത്രമേ y വാല്യൂസ് അവൈലബിൾ ഉള്ളൂ. സോ ഈ ടേബിളിൽ നമുക്ക് കാണാൻ സാധിക്കുന്നത് ആർഗ്യുമെന്റ് ആൻഡ് എൻട്രി. ആർഗ്യുമെന്റ് ഇസ് എക്സ്, so the first argument is x0 and the corresponding entry is y0. So what is y0? It is nothing but f of x0. Similarly, the next argument is x1. So since I told you this is a section we deal with the equal intervals of x. അപ്പോൾ x0 ൽ നിന്നും h കൂട്ടിയാൽ x1 കിട്ടും. x1 ലെ എൻട്രി ആണ് y1. y1 എന്ന് പറയുന്നത് f of x0 plus h ആണ്. അപ്പോൾ ഫംഗ്ഷൻ റിമെയിൻസ് ദ സെയിം. ആ ഫംഗ്ഷനിലേക്ക് x0 പ്ലസ് h ആഡ് ചെയ്താൽ ഇട്ട് കൊടുത്താൽ നമുക്ക് y1 കിട്ടും. അടുത്ത ആർഗ്യുമെന്റ് x2 ആണ്. x2 എന്ന് പറയുന്നത് x0 പ്ലസ് 2h ആണ്. അപ്പോൾ x0 is the starting x value. So if you add 2h, that is the step size h into 2, you will get x2 because all the points are separated by equal distance. So x3 is nothing but x0 plus 3h. The entry will be y3 is equal to f of x0 plus 3h. Similarly, the last point xn is equal to x0 plus nh, and the corresponding entry is yn is equal to f of x0 plus nh. So this is what the basic table of a discrete function. So now let us come to what you understand by forward difference. So now how to find the forward difference? So if we subtract from each value of y the preceding value of y, we will get, for example, I am subtracting y1 minus y0. I am finding y1 minus y0. So then I subtract y2 minus y1. So I'll make y3 minus y2, y4 minus y3. So you subtract a value of y which from the preceding value. So you subtract the preceding value from a next value. So that is called as first difference of y. So these first difference are denoted by delta y0, delta y1, etc. up to delta yn. For example, so if I ask you what is delta y0, you have to say y1 minus y0 is called delta y0. If I ask you what is delta y1, it is nothing but y2 minus y1. So a y value and then minus of the previous y value is called the first difference. Now what is the operator, the first forward difference operator? This delta is the symbol that represents the operation of forward difference, and this is called as first forward difference operator. So you can represent generally delta yi is equal to yi plus 1 minus yi. So I plus 1 is nothing but the y value, a particular y value, minus which is corresponding to I plus 1. So I can be some integer, and minus yi that represents to the previous y value. So now I can define the second difference. So the first difference is nothing but the difference in y value. So the second difference is defined as delta square y0 is nothing but delta of delta y0. That means it is nothing but delta y0, delta y1 minus delta y0. So the differences of the first differences is called the second difference. So if I ask you what is delta square y0, you should say it is delta y1 minus delta y0. So but delta y1 is nothing but y2 minus y1. Then what is delta y0? That is y1 minus y0. So delta square y0 will be nothing but y2 minus y1 minus of y1 minus y0. So that will be y2 minus 2y1 minus plus y0. So you can express the second difference in terms of the y differences of y values. So basically it is defined as the second difference is nothing but the differences of the first difference. So if you subtract first difference with the preceding value of the first difference, you will get the second difference. So that is what you call as the second difference operator, that is delta square. So delta square y1 will be nothing but delta of delta y1, that is delta of y2 minus delta of y1. So what is delta of y2? That is y3 minus y2. Delta of y1 is y2 minus y1. So delta of delta square y1 will be y3, that is delta y2 minus delta y1. Delta y1 is y2 minus y1. So that will become y3 minus 2y2 plus y1. So similarly, you can find out delta square y2, delta square y3, like that you can find. So this is what we call it as the second difference. So why I am finding all these things is because I am going to do numerical differentiation. So what is numerical differentiation? You are differentiating a function not by using a equation or a formula or an analytical method. So you are doing mathematics in a different way, and that type of mathematics is called as numerical mathematical methods. So you can differentiate a function. It is not a function. Basically, you are differentiating using a given value, a set of values, and you are finding the different derivative at a particular value of x using the numerical value. So similarly, you can find the nth second forward difference operator. So second forward difference operator is delta square yn. That will be delta of delta yn. You can write it as delta of yn plus 1 minus delta yn. Delta of yn plus 1 minus delta yn. So that is the general expression for the second forward difference operator. So in general, you can think about third forward difference operator. That will be delta cube yn. That will be delta square yn plus 1 minus delta square yn. So that can be again written in terms of delta yn, and that again can be written in terms of yn. So in short, you can think about nth forward difference operator. So delta square cube yn, delta raised to 4 yn, delta raised to n yn. So delta raised to n yn will be nothing but, you can just say that delta n minus 1 y k plus 1 minus delta n minus 1 yk. So here what I am doing is, when I speak about delta square yn, I was thinking, I told that it is delta of delta yn. Delta of delta yn. That means delta square yn is nothing but delta of delta yn. So that means I have subtracted 1 degree. That is, I am finding delta square, but I am saying delta of delta yn. That is, power is 1. So here I want to find delta nyk. So delta nyk will be delta n minus 1 yk plus 1 minus delta n minus 1 yk. So that means you are finding the differences of the n minus 1th difference. That means the difference of n minus 1th difference is the nth difference. So nth difference operator is nothing but the difference of the n minus 1th difference operators. So that is what the general form of the nth forward difference operator. So in this, all these operators can be put in a table. So you can see in this slide, you can see I am putting all the difference operators in a table. So in the first column, you can see the argument. Argument is nothing but the x values. So it's a discrete function. So only at a certain intervals we have the x values, because it is not a continuous function. So the separation, the step interval is h. So first point is x0. So similarly it goes on, and the second thing is y, that is the entry. Entry is nothing but you have to put the value of x, corresponding value of x in the function, that you will get the value of entry. And then the first difference operator is nothing but the differences of y value, and the second difference operator is nothing but the differences of first difference operator. Similarly it goes on. So if you want to find any column, you take the differences of the previous column. So just take the differences of the previous column, you will get the particular column. So now what I am going to do is, using this difference, you need this difference operator values. These difference operator values can be used for integrating numerically. Now again we come back to the interpolation. So interpolation is basically a technique of obtaining a value of a function for any intermediate value of the independent variable. For example, I am having x0, x1, x2, x3, and I told you x1 is nothing but x0 plus h. What is x2? x0 plus 2h. So like that it goes on the arguments. We have a discrete set of arguments. So correspondingly I am having the values of entry. So that means y is equal to f of x. Now I want to find a value of y for a x value, but that x is not in the table. So that means x0, after x0 it is x1. So I want to find x0 plus h by 2. That means in the midpoint of x0 plus x1. That is not in the table. So if I want to find out the value of y, you can choose any value of x. That is your choice, because it is your control, because the independent value is controlled by the user. So the system will evaluate the value of the entry based on the value of the independent variable. So now if I want to find the value of x0 plus h by 2, that can be done by interpolation. So now if I want to find the value of the function outside the given range, that is called extrapolation. So I am having a range of x, that is x0 to xn. So that means the first point is x0, the second point is x1, that is x0 plus h, the third point is x0 plus 2h, like that it goes on, and the last point is x0 plus nh. And you want to find a value of y for a given x which is inside your range, that means in between x0 and xn, and that is what is called as interpolation. Suppose I want to find out the value x in plus h by 2 or outside the range of x, then I call it as extrapolation. So now by simple substitution, what we do is we have to get a polynomial. In the last class we studied using a polynomial. I did the interpolation, and the interpolating polynomial can be you have a lot of coefficients, and you know how to find the value of coefficients, and find the coefficients can be expressed in terms of the given data values. So the differences in data values are used to find out the coefficient of the polynomial, and that is what we call as polynomial interpolation, or the polynomial is called as interpolating polynomial. And this process of using of interpolation by using a polynomial is called as polynomial interpolation. Suppose if I have a trigonometric series, that is fx is a finite trigonometric series, then I call this process a trigonometric interpolation. So usually the polynomial interpolation is preferred due to the reason that they are free from singularities, and you are easy to manipulate a polynomial. You can differentiate a polynomial, you can integrate a polynomial compared to the trigonometry. So that means so I told you what is the finite difference. That means the first forward difference, second forward difference, like that I told you. And now I am going to use this in this process of interpolation. So we are going to derive that interpolation formula. So let me start, and this formula is called as Gregory-Newton forward interpolation formula. So the requisite things are information are given to you. First of all, you know what is difference formula, difference operator, what is first difference operator, second difference operator, how to find that, and what is interpolation, what is extrapolation. With this information, and you know what is a polynomial interpolation. And in the last class, we studied how to use a polynomial and how to find the coefficients of a polynomial in terms of the data points. Now we are going to derive this Gregory-Newton forward interpolation formula. We start with a function. It is a discrete function. As I told you, they are the values x0, x1, xn, corresponding values of y. We have again the step interval xi is equal to x0 plus ih. So all these things are to you already. So now I start with the general expression of a polynomial. Any polynomial can be expressed in terms of a sum of terms. That is, sum of terms having the first term is a constant term without a variable, independent variable, and a product of a coefficient and a variable, and a coefficient and a product of two variables, like that. You can say that yx is a function. So you are expressing any function in terms of a polynomial. It is possible any function in the world can be expressed in terms of a polynomial. So how will you write a polynomial? Polynomial has a general form, that is a0 is a constant term. You can put any term. A0 is a constant, a1 x1 minus x0, x minus x0, a2 x minus x0, x minus x1, a3 x minus x0, x minus x1, x minus x2, plus a4 x minus x0, x minus x1, x minus x2, x minus x3. So like that it goes on. The last term will be an x minus x0, x minus x1, etc., etc., x minus of xn minus 1. So this is the starting step. That is, we have started with a polynomial, and that polynomial is what we have written here. So the next step is you want to find the coefficients of this polynomial, that is equation number 1, in terms of the data points. That means the data points are x, not the data points, in terms of the difference operators. So I told you the first difference operator is delta y0. So what is delta y0? y1 minus y0. So what will I do? I just put the values of first point, that is x. I know the value of x0 and y0. So I put the value of x0, y0. What will happen is all the terms, all the terms from the third term will vanish off, because x minus x0 is 0. Because if I put x equal to x0, all the terms will vanish, will vanish. So only thing left out is the first and the second term. That means a0 plus a1 into x minus x0 will remain. So if I put x equal to x0, the second term also vanish. So only the left out is a0. So the value of a0 is nothing but y0. Similarly, I got the value of a1, that is, if I put the value of x is equal to x1, I will get the value of a1. So that means x1 minus y1 minus y0 by x1 minus x0, that is delta y1 delta y0 by h. Similarly, I can find the value of a2, and finally, generally I find the value of a3, that is the coefficient a3, that is delta cube y0 by 3 factorial into h. So now I am taking a general point x, that is x minus x0 by h is equal to p. That means I take a point x, and I want to find the value of the y at that point x. So x minus x0 by h is p. So what will be x? That is ph plus x0. So equation 2 is rewritten in terms of p. So what will I do is, I just replace x minus x0 by h is p. So I'll write p into delta y0, and delta square y0 into p minus 1 by 2 factorial. And then I write p into p minus 1, p minus 2 by 3 factorial into delta cube y0. And in general term will become p into p minus 1, p minus 2, etc. p minus of n minus 1 by n factorial into delta n y0. So this is what I called as Gregory-Newton forward interpolation formula. So why I am calling this as an interpolation formula? Because see, I am finding the value of y at a given value of x. See, I don't know the y value at that x value, because I have only x0, y0, x1, y1, x2, y2, like that. So these discrete points x, I have only the discrete x values and the corresponding y values. But in between, I choose one x value, and then I found the value of y for that x value. So that means I am finding the value of y at a x value, and then I am expressing that y value in terms of the data available. That is, the available data is x0, y0, x1, y1, and the differences of the y and the p value. So p value can be easily find out. So this is what I call as Gregory-Newton forward interpolation formula.